Good evening, everyone. I am Anup Tiwari, co-coordinator of Faculty Development Program on recent trends on wireless technology, 5G, 6G communication. In just a short while, we will start our session. Just we are waiting some more participants to join. Exactly at 6 o'clock, we will be starting our program just within a few minutes. So today is fourth day of our faculty development program, and seventh session will be starting at 6 o'clock. So I'd like to introduce our speaker for today for the first session. Uh, as you people already know, we had a one session with Mr. S. Vivek sir previously, day before yesterday. Today, one more session will be held by him. I'd like to introduce Mr. S. Vivek. He is BTech and MTech from JNTU Hyderabad. He has done MBA from IIM Indore. He is currently working as SDE in BSNL, including training centers. He has a specialization in wireless communication, 4G, 5G, 4G, 5G, 6G, IoT, telecom networks, MPLS, VPN, machine learning and deep learning, NLP and computer vision. He has delivered several talks and lectures for various organizations like Indian Railways, BBNL, Railtel, NITTR, NMDC. He has also spoken in universities like HCU, MANUU, SRM, VIT, Manipal, Geetam, KLU, some IIT companies like Verizon, Cyient, TCS, etc., and many engineering colleges, including CBIT, VNR, Vardhaman, Gokaraju, Sridevi. He has guided more than 4,500 students for internship and projects from 2019 to 20. He has received official appreciation for 3 years from 2019 to 2020. I will request Mr. S. Vivek sir to please start his presentation, sir. Sir,
Thank you.
please. Hmm.
Thank you very much, sir, for your nice introduction.
Welcome,
Shall we
sir.
wait for a while, sir? Can we start?
It's already 6 o'clock, sir. If you are ready, you can start now.
Okay,
Only.
I will start. Thank you.
Okay, sir.
So once again, I thank you for your nice introduction. And today's topic we will discuss. But before we discuss, good evening, all of you. Good evening, all the participants and faculty members. Uh, uh, the topics for today's session is RF technologies of 5G and 6G. In this session, we will discuss about the introduction of this topic and 5G RAN key features and 5G use cases, 6G introduction, 6G RAN key features, challenges, and future outlook. So these are the various things. So mainly the key features we will discuss about the 5G as well as in 6G. Before we start, we need to first look at how is the mobile evolution is there. The last session also we discussed the mobile evolution up to 5G. When we look at the evolution, there's a particular pattern that we can observe. The pattern is from 80s, first generation has started. Every decade you can see 80 first generation, 90s second generation, 2000 third generation, 2010 fourth generation, and 2020 fifth generation. But you will be surprised that there is a notion that the 6G may come before 2030. So that's why the timeline has given as 2025 to 2030. Somehow 2025 has come and the 6G standardization is in under process currently, but not yet come because of the commercial concentrations. Because 5G, though it has completely deployed, 5G FR2, 5G complete standalone deployment across the globe, across the countries, will still take some time because of various challenges which we have discussed in the last session. And coming to this, the first generation it talks about only the analog, and the second from second generation till now everything is completely digital. So digital is the baseband signal, the baseband voice, the baseband the data will be in the form of digital data. So that is in the ones and zeros. So whatever the generation may be from second generation, it all is carrying the baseband data is in the form of digital data. So second generation is called as GSM, Global System for Mobile Communication, and third generation is called as UMTS. There is a stark difference between second generation and third generation. As we know, second generation uses the radio technology, which is the most key thing in the entire cellular communication, the entire mobile communication. Out of all the systems, if you take the user system, access system, and core system, the radio access system is the most complex and challenging thing to be implemented because it is involves the spectrum, it involves a wireless interface. So to implement the wireless interface is always challenging. To implement the core network, to implement the access network and core network connectivity, you can use the optical fiber, you can use the wireline connectivity, whereas for connectivity from user to the access or the base station is all completely wireless, and that's the challenge the cellular mobile technologies have involved. So the second generation is global system for mobile communication, which uses the FDMA and the TDMA combination. FDMA stands for frequency division multiple access, and TDMA stands for time division multiple access. So FDMA and TDMA combination is used in second generation. That means in order to utilize the available spectrum for the large number of users in that cell area or in that coverage area of a base station, the available spectrum is to be divided or shared among several users by adopting a technology called as frequency division multiple access, and then, in combination with time division multiple access. When it comes to third generation, which is called as UMTS, Universal Mobile Telephony System, it uses the radio standard called as radio technology called as WCDMA, wideband code division multiple access. So there's stark difference between FDMA, TDMA, and CDMA. Because FDMA, TDMA talks about different frequency and usage of different time sharing of the same available frequency resource. Whereas in third generation, wherever you go, as we know, as we said last time, also we discussed that in order to increase the capacity, in order to meet the increasing demand of the SIM cards, in order to increase the, in order to rise up the bar, in order to scale up the available capacity, the third generation networks they will be obviously will be adopting what is called as cell splitting or cell sectorization. So large number of cells will be there to provide the access or the quality of service. To provide the access or quality of service, these cells should have no some frequency carrier, some spectrum will be there. But if you go across all 3G cells in a service area, all the 3G cells will have same frequency. But what will be the difference? The difference will be the code. That is, spreading codes are used. That is why it's called as WCDMA. When compared to normal second generation CDMA, wideband means 5 megahertz carrier is used, as we discussed in the last session. So that is the difference in third generation. But from fourth generation, fifth generation, sixth generation, they're all using what the radio technology, which is called as OFDMA. Fourth generation, as we know, it's called as LTE, long-term evolution. Long-term evolution, and 5G, which is known by technology called as NR, new radio, uh, and 6G. The name is not yet confirmed, but 6G also talking about new radio technologies, new and also the softwareization of the core network. The 4G, 5G, 6G, they're all using what popular technology called as OFDMA, orthogonal frequency division multiple access. We can say this is a higher, you can say it is a improvisation of the basic FDMA. As we have also seen that in the last session, FDMA, what is the major difference between normal FDMA and OFDMA means? In OFDMA, we will be using a small subcarriers, and in 4G, 5G, and 6G, we will be using small subcarriers, with this cyclic prefix customization will be there in 5G and 6G, and that is not there in 4G. That is the only difference. Okay. And one more thing, what you can see is the application from first generation. If you see first and second generation was focused on only carrying the voice. The cellular networks were designed to transport the voice in a wireless form. And of course, in second generation, what is the new add-on feature is SMS, which is a great feature, and which still existing. Still, we are relying on OTP service for security. One of the layer for providing the data communication security is the SMS, that is through OTP service, one-time password service. So that still it is there, though the second generation got obsolete. And the third generation, what is the major focus area or the major the thrust area is the internet service. And from fourth generation, the thrust area is the Internet of Things, IoT, MMTC applications, massive machine type communication. And from fifth generation, now we have multiple diverse applications, as we have discussed earlier. URLLC, that is low latency, ultra reliable applications, and IoT, MMTC, massive machine, and enhanced mobile broadband. These are the diverse applications which is provided by the fifth generation. Okay. And coming to the sixth generation, it is talking about fully connected world. Fully connected world means still now we are just talking about terrestrial communication. And from 5G, not only terrestrial, so even there will be in-flight communication. It is talking about the standards of in-flight communication. And there will be, of course, 5G also, some releases have talked about satellite integration, and 4G also talked about integration with the WLAN networks, Wi-Fi networks. So 6G talks about no, not only integration of WLAN, not only integration of terrestrial networks, but also integration of the civil aviation networks. It may be the satellite networks. It may be the even the shipping navigation networks. So whatnot, everything. Apart from the connectivity, it also talks about fully connected world. That is the USP of 6G. For that, you need to have more spectrum as well as more refined technologies. If you look at the first, let's see, as we have discussed in the agenda, we'll look at first 5G and its key features and key technologies, followed by the 6G and 6G technologies. If you look at 5G performance, it has immensely, the 5G performance has immensely increased. As we can see, the data volumes have increased by 1000x, and number of connected devices have increased by 100x, whereas latency reduced by 5x, and the end user data rates, end user throughputs have been increased from 10x to 100x. As we have seen, 4G talks about speeds up to 100 Mbps, whereas 5G is talking about speeds in the range of 1 Gbps, more than 1 Gbps. And even the 5G and advanced 5G plus, it talks about speeds in the range of 30 Gbps also when we are using FR2. When FR2 mm wave is in picture, it can also provide by using massive MIMO antennas. It can also provide more than 10-20 Gbps also. So that's the range. That's the kind of speeds the end user speeds 5G can provide. And as we have seen, but these all full-fledged specifications can be provided only when FR2 and all the frequencies, whatever frequency carriers are there, are full-scale standalone mode, and also the complete spectrum is available with the operator. And 10x battery life for low power device. So even the battery life also improved by 10x. So what are the standardization bodies for this 5G? And of course, we also see for the 6G, same bodies exist. So there are two different bodies. One is the International Mobile Telecommunication of ITU. So ITU is a governmental body, the governmental agency, International Mobile Telecommunication. For defining the 3G standards, IMT 2000 has been formed. And IMT 2000 means this is a specific subcommittee, you can say. It's a subcommittee of the ITU. This body is specialized, is only specifically focusing on what should be the standards, what should be the features, or what should be the services that can be provided through a third generation in IMD 2000. Then followed by IMD Advanced for defining the LTE standards, for 4G standards, and for 5G standards, IMD 2020. So IMD 2020, this subcommittee of the ITU, which is a part of UNO, International Telecommunication Union, which is a governmental agency, as I said, is talking about the 5G and of course NR also. So you can see the releases, and what are these releases means, like versions. See, 3GPP is an industry body. It's, you can say, standardization, and it's a forum of standardization bodies of various countries. Standardization bodies like TEC, Telecommunication Engineering Center, which is Indian standardization body for telecommunication standards, or the product validation, and product validation, you need to have some standards. TEC is for India, whereas 3GPP is mainly dominated by European Telecom Standards Institute, ETSI, as well as FCC, and US Telecom Standards Institute, as well as the Chinese, and then Japanese, and then from South Korea. These are some of the major players, major standardization bodies which are behind the 3GPP. So 3GPP is the major industry player, you can say. IT is only the governmental agency which broadly give the guidelines of the different generations. So, but in fact, all the service providers, all the you can say the suppliers, or the telecom vendors, are the equipment manufacturers, the TEMs, the telecom equipment manufacturers, are the original equipment, what you say, OEMs, original equipment manufacturers. These OEMs are suppliers, or the vendors. They have to adhere to the 3GPP standards, because interoperability is the key issue to follow the standards. So if there is no standardization, and if there is no adherence of the standardization by the individual operators or the suppliers, and integrators, even the what are the other players in the ecosystem. This telecom ecosystem is, apart from the customers, we have the service providers, which, for example, in India, the service providers like Airtel, Vodafone, and Geo, including the government service provider like BSNL, like AT&T in US, or Verizon, Etisalat in Dubai, or Telstra in Australia, or Vodafone in UK, or British Telecom in UK. So these are various service providers. Apart from service providers, what else is required is the suppliers are original equipment manufacturers like Ericsson. If you take Ericsson, they are the market leader in providing this equipment, or the and market leader in R&D of the telecommunication standards and technologies. Ericsson, are and the Chinese Jetty, Huawei, they were there, but because of the post-COVID regulations, including India, some of the countries have started regulating the import of the Chinese equipment. And then we have the Motorola, Samsung, and also people like Alcatel Lucent, and yes, and Siemens also. And these are some of the companies which are called as original equipment manufacturers. And these also are a part of ecosystem. And apart from the suppliers or the vendors or original equipment manufacturers, we also have another ecosystem player, a stakeholder, who is called as integrators. So integrators, of course, some of the companies have their in-house integrators, but most of the times now the vendors are taking the help of the third-party integrators. These integrators are playing a key role currently for the deployment of any network, 5G or 6G, that the integrators like Gemini Networks, the integrators like ATC, and also other players like tower supply companies. So these are the various players, and all these players have to adhere to the 3GPP standards. So it's a global initiative of the standardization bodies. And coming to the 5G, the technologies, the key technologies, key features which are existing. And as we have seen in the last the day before yesterday session, we talked about mmWave, that is FR2 range, frequency range 2, which uses frequencies in the range of the wavelengths 1 mm to 10 mm. and that's a game changer in the 5G use speeds 5G can offer. Apart from it, what are the other things? See, the new waveforms and frequency band, which we have already talked about, as briefly discussed. And apart from the wave and apart from the FR1, FR2, what else are there? Is a scalable. As I said, told, if OFDMA is used in air interface or radio interface, apart from the basic OFDMA which is used in 4G, it has scalable OFDMA. So scalable OFDM will say scalable because the CP can be changed, or the subcarrier size is customizable. So subcarriers from 15 kilohertz we can use up to 60 kilohertz or more. That the flexibility is there. As well as cyclic prefix also you will be using. It can be customized in order to control the inter-symbol interference, or depending on your planning requirement. If it is an outdoor area, if it is an indoor area, or if it's a dense urban area, or rural area, depending on it, and also CP can be customized. Ultimate aim is why the customization is there, or why the scalability is there. The ultimate aim is to have more energy efficiency, to have more uh, performance. These are the two objectives: performance in the terms of quality of service, and energy efficiency. Energy efficiency has a lot of benefits, like the total power consumption will be reduced, and also battery power consumption will reduce, means it will be providing better quality of service, better experience to user. And massive MIMO beamforming, adaptive channel coding. There are also one of other techniques which are being used. CRAN. CRAN talks about Cloud RAN technology. So we also discussed about what are the CRAN features that are there. Last session, some of them have asked about one doubt they have asked about CRAN, that also we discussed. And HETNET feature. And last time one madam, like I think Padma madam has asked about this have overlaid or underlaid feature. So overlaid cells is nothing but HETNET. So there is a combination of HETNET, heterogeneous network. So that is also one of the key features. These all features combinedly with the help of edge computing in the RAN is making the 5G much better than its predecessor technology, which is making it have 100x better data rates and 10x better latencies, and 100x capacities, and all these are possible because of combination of these technologies and customization possibility. So, and another design philosophy in 5G is the 5G NR as we have seen, there are several technologies are there, like RAN features you have seen. The flexibility is there because the customization I told, scalability is there. You can use multiple cyclic prefix, you can use multiple subcarrier sizes. So that flexibility is there, and also wide range of frequencies. Wide range of frequencies means it can use either FR1 or FR2. In FR1 also, last time some faculty members have asked, in the FR1 also we have frequency bands from 700 megahertz. We are the 5G can support carrier aggregation. Carrier aggregation means a user. Suppose a user is to be given 100 megahertz carrier size. The 100 megahertz carrier size cannot be taken from one chunk of spectrum. We can take it from one band. Let's say you can out of 100 megahertz, 20 megahertz can be taken from 700 band, and 10 megahertz can be taken from 1800 band, and maybe some 20 megahertz from 900 band, and another 50 megahertz from maybe 2.5 gigahertz band. So like that, we can take multiple bands together. We can make a carrier that discrete sets of frequency chunks can be aggregated and can be given to one user for one service. So that is the beauty in 5G. That's called as carrier aggregation. That flexibility is there for choice of frequencies depending on the availability, depending on the licenses available, depending on the conditions available in this respective countries, respective license service area. And deployment strategies. Also, deployment means if a rural area, what is the plan? Urban area, what should be the plan? Hilly area, what should be the plan? Or Ghati area, what should be the plan? So these are the different type of requirements will be there. And such ultra lean architecture. Ultra lean architecture means to reduce the latency.
Sir, one question. If you are saying in CA, multiple frequency can simultaneously we can use, then how to reduce the aliasing?
How to reduce the
Aliasing effect. Aliasing effect. Alias.
alias effect, madam.
Yes, 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 sir.
Because we can this feature is there because the oscillator will be tuned in such a way that the frequencies from various bands can be combined, and you will be having the what is the technology is used is that in that these uh, we are using DSP chips, that the discrete Fourier transformation, the FFT is used in such a way that they are so much advanced and so much refined that whatever side bands that are there, whatever harmonics that are generated, they are filtered out by using that advanced filtering system that is used in the our 5G, madam. Am I clear, madam?
Okay, 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 sir. Okay, sir.
Okay. And ultra lean, the purpose of all this ultra lean is for the long term sustainability, because if the number of network elements are more in number.
One more doubt, sir. Filtering you are saying, no? What type of filter you are using, sir? Matched filter?
Madam, what filters?
What is the name of the filter, sir? Or what type of filter?
Yeah, we are using almost all type of, we in the same if you take the base station, madam, the base station will be using the band pass filters, it will be using the low pass filters, it will be using the high pass filters, and also it will be using the no of course, apart from it will also use the power amplifiers, it will also use the low noise filter. So it's the filter combination, we can say it's all about we are using adaptive filtration is being used, and multiple filters with adaptability feature is being used currently.
Depends on our application, we are using, we can change the
depending on that context, it is the adaptability will be there, all will be there, depending on the context it will be adapted, and that's why the base station is called as base station is now called as from fourth generation SDR means software defined radio. Last session now we have seen was, madam, complete architecture. In the architecture you have seen it's called a service based architecture. The core network is converted into service based architecture, and the core network functionalities are now called as NF. They are the virtual network functions only. Similarly, the base station also, they are now called as SDR, software defined radio. Software defined radio means the software can be controlled by a remote center dynamically as per the traffic conditions, as per the requirements of the that operator, and as per the policy defined.
Okay. Okay.
Yeah.
Right.
And,
so for that we have to define the traffic first. We have to.
Yeah, traffic will be live number. Initially for planning stage, traffic will be taken by considering the survey requirements, and also you will be having, suppose you are launching 5G means already 4G traffic reports will be there. You have an idea. If you are launching 4G means 3G traffic reports will be there. So you have an idea, and we know where the congestion is happening, where there is a lot of requirements, because the sites will be deployed where actually the gap is there.
Traffic is more, congestion is more.
Congestion is more, where the scope is more, or where the potential is more, or marketing reports also will be there. So there, the traffic reports will be taken as well as, of course, your marketing. So yeah, because it depends. So sometimes
how you are getting the data, sir?
The survey will be done. One thing, survey will be done. And as well as the primary information will be always the traffic reports, because already the industry is matured now, madam. Industry is completely developed, matured. The traffic reports will be generated by every base station, every sector. So every sector, and that will be captured almost every few milliseconds, or you can say every few seconds. And that information will be collated, and it will be aggregated, and it will be pushed to the operator dashboards. Every hourly reports will be taken, hourly traffic reports will be taken, and they will be averaged upon. So that we will be, these are all NMS features for managerial decisions they will be taking.
Okay, okay, sir. Thank you, sir. Thank you, sir.
Welcome. And ultra lean also, I think you understood the concept, because if the number of network elements are lesser, that will be a good feature for sustainability. Sustainability of the environment, sustainability of the equipment, sustainability of the whole service also. So if the more number of network elements are there, so more processing is required, more capex, more opex, and all, and also more burden and impact on the environment. So ultra lean is one of the feature for the green, can say green technology. It's like a green technology. And also forward compatible. Forward compatible means the 5G why it's forward. Normally we all are aware that backward compatibility is the keyword. Similarly, forward compatibility means why 5G is more forward compatible, that is to 6G. Why? Because the core network, as we have seen, it is based on service-based architecture, and core network layers are connected by APIs only. APIs means any software. Normally, if you take any IT company, they will be developing the APIs, and you can easily connect different apps by an API. So you can integrate the apps by an API. That's what they are doing. And the applications, no, if you take authentication server, one application will be developed by X company. If you want an mobility management application, it will be developed by Y company. So earlier it was not the case. Earlier all the functions, all the core network capabilities will be developed by X company only. So we cannot have multiple vendors in the same core network. That was the scenario. So that proprietorship used to be there till 4G, but from 5G that is completely universalized, and because of softwareization technology. That means softwareization means nothing but the core network is completely now in the hardware does not have any reliance now. Hardware will be just like a we'll be calling it as uh, OTS hardware. OTS means off the shelf hardware. Off the shelf means whatever that is available. Suppose if you want to buy a laptop, or if I want to buy a mobile, what will be buy? Simply if you go to Amazon or Flipkart, you'll have multiple options. Similarly, the servers also can be bought. You can buy an HP Blade server, or a Dell server, an IBM server. You will have multiple options. So hardware of the cloud it does not have any significance. It is just like a basic commodity. It became a basic commodity. Earlier, up to 4G, all the service providers across the globe, they have to follow the hardware and software, or inbuilt software with the hardware will be from a proprietary source will be there. Maybe Ericsson or Jetty or no Siemens, something like that. But now it's a radical change. From 5G, the core network has a radical change, and that's the one of the reason in the evolution also I have shown you. From 5G to 6G, it is taking less time. And from 6G to 7G, it may not take a decade. Only the requirement may be financial or commercial viability only. There's a problem. But from technological jump will not take much more time. Why? Because the core network got softwareized. Only what are the features that will be changed means there will be add-ons, and there will be some developments in the RF technologies. Okay, madam. So these are some of the driving principles or design principles of 5G NR. And as I told you, the 5G or this 6G, they are having diverse scenarios. They are capable of providing diverse scenarios. So diverse scenarios, you can see here. They can provide not only. See, I hope you can find it out. Yes. So diverse scenarios like apart from providing ultra dells cells. For example, these are the cellular cells in which many base stations are there, and they provide the coverage as a normal thing. They can provide macro cells, they can provide micro cells, they can provide FEM2 or pico cells. Apart from these traditional different types of cell sizes, they can also provide M2M communication, IoT. This also we discussed, IoT communication or machine-to-machine communication. One thing. The other thing is vehicle-to-vehicle communication. One of the byproduct of the IoT or M2M communication is a vehicle-to-vehicle, V2V. It is also clearly defined in the releases, 3GPP releases. V2V communication, V2A communication, A2B communication. So vehicle-to-vehicle communication comes, they have a greater effect, as we have seen the Tesla example, driverless cars, or you can see the autonomous vehicle systems. So they if you are having multiple autonomous vehicles on the road, there should not be any collision. So vehicle communication that is will be like D2D communication. I hope some of you might have already done some research publications in D2D communication. So D2D communication is no, it is not completely no, implemented on its own. It will be one subset, one of the feature, just like how micro cells will be there, how overlaid cells will be there, how umbrella cells will be there, how a pico cell will be there, how multiple cells will be there, depending on the customer requirements, or different depending on the topology of the network. Similarly, D2D communication is also, D2D means device to device communication also. But what's the advantage of D2D? Obviously, I think device to device. We need not a device. Normally, if you take a 2G network or a 4G network, a typical network, a device has to, if you have to communicate with another device within the same room, it has to go to the base station. Base station has to send it to the core network. From core network again, it comes back to base station, and again from base station it has to come to the device to which is in the same room. But device to device completely altering the nature. So device to device, suppose if they're in the near far NFC communication, suppose if they're having Wi-Fi integration, if they're having the Bluetooth integration, as I told you that the 3GPP releases also talks about integration of or offloading of the cellular, that is OFDMA, or you can say the 5G radio network to the Wi-Fi also. That integration is possible. That offloading is possible. That's already in place. Even we have also implemented from third generation itself. So that WLAN integration is there. With the help of WLAN integration, or with the help of any other NFC, the device to device can be communicated. So thereby the latency will be largely reduced, because there is no need of processing power. No, base station will need not process your signal, and then that milliseconds also will not take place. The core network also, multiple network functions will be there which has to process your requirement. All these things gets skipped off when the device to device is there, but it's all limited functionalities. So limited applications will be there. No, maybe in a retail chain, or maybe in a proximity applications, or maybe no. So these are the limited use cases will be there. So in such cases, maybe in a shopping mall, it can be possible, or maybe in a big retail store, it can be implemented. So that's, as I told you again, the use cases are the pulling factor should be there to adopt it by the operators in a large scale. Apart from the other diverse case scenarios is the multi-tier COMP transmission. Multi-tier COMP transmission and heterogeneous network are almost related technologies. COMP means coordinated multi-point transmission. Coordinated multi-point transmission means, so it's also significant. It's like a revolutionary change when compared to the predecessor technologies. Coordinated multi-point means a mobile phone can coordinate with multiple base stations at the same time. That means uplink can be used by one base station. Maybe a low power base station is there, which makes the downlink connectivity to the mobile phone, whereas the uplink connectivity can be made to a large power base station, or maybe downlink can be done by a large power base station, and uplink can be done to a low power base station, or multiple, or maybe a downlink. You can have, suppose if the customer is having large data rate requirement, then he can get the some of the bit rates from the X base station, some bit rate from the Y base station, some bandwidth from the Z base station at the same time. Because as I told you, in a dense urban scenario, this will be the dense urban scenario only. Dense urban scenario, you will be having a base station, a 5G base station every 300 meters. Every 300, if you take a dense station like an Abits, or if you take any city center within the outer ring road, everything is a dense urban only, as we know. If you take any place, Gachibowli, or in a Madhapur, or any Kondapur, or Kukatpalli, or any place, all are dense urbans. No? So if you take, they will be having every 300 meters or every 250 meters you will be having, or less than 200 meters also may be there. So that cells, in the same base station, the same mobile phone can be connected to multiple base stations. So it will be connected to maybe 3-4 base stations, and all the 3-4 base stations, they can coordinate with each other, and they can provide aggregated bandwidth to the user. So that's that's if the user is having that privilege, user is having the policy defined, maybe our user he's having that quality of service profile, QS profile as per his features, as per his plan, as per tariff plan, etc. That also can be given, and that feature, that facility is also there. It's called as coordinated multi-point. And then IoT. IoT, as we told, M2M and IoT is almost similar, but machine to machine is purely industrial applications. IoT can be home user also. And of course, relaying, as this is also some other parts, the speakers also talked about relays. Relays are nothing but repeaters. We can use the device as there will be multi-hop transmission, multi-hop transmission. We can have a relay. We can use, suppose if you want to extend the signal to a more to a greater area, geographical area, then you can use as a relays. You can use some base stations as relays, as mobiles as relays. You can use cascading to reduce the backhaul requirement. So multiple options are there. Coming to the main one of the key technology, because I'm just skipped up the mmWave because we have already discussed. So one of the main key feature is multiple frequency forms, FR1, FR2, which we have seen in the last session, the sub 6 gigahertz, as well as FR2 talks about the 24.2 gigahertz to 52.6 gigahertz. So that is the big chunk which talks about 1 mm to 10 mm wavelength range. So that range, the FR2 will be, if suppose FR2 is used, we need to go for massive MIMO antenna. So massive MIMO antenna, this also I just told you, I am going to use some slides. The large number of antennas will be there. Maybe in one base station you will be having the antenna, one sector antenna will be having more than 256 or 512 antennas. And the purpose is, it can provide that can simultaneous data transmission to multiple users, which will improve the overall network performance or overall throughput. Or no, maybe multiple antennas will be used for a single user who is having very poor radio conditions. Radio conditions will be monitored by the network 1,000 times in 1 second. Once if you take how the we'll be calling it as scheduling, the base station schedules in such a way that it is so at a much faster rate that it will check every mobile station's radio conditions 1,000 times in 1 second. 1,000 times every 1 millisecond means every second it will verify your phone 1,000 times. What's your radio condition? What's your radio condition? What's your radio condition? Every millisecond it will verify. Depending on the radio condition, the resources will be allocated. The resources means the PRB, physical resource block, the subcarrier, the group of subcarriers, or how many symbols should be there. What is the modulation rate? So every second, it will customize what should be the modulation. Whether the modulation should be QPSK or 16 PM or 64 PM or 256 PM. So what modulation should be given to you at that instant? Apart from it, how many subcarriers should be given, and how many symbols should be given? All these things. Apart from it, what QS profile should be given? You should have a given with a COMP feature or multiple transmission features, or what profile should be given? Whether it is an MMTC profile, or whether it's a EMMB profile, or whether it's a what kind of layer you need to provide. It also will be decided. And apart from it, the massive MIMO antenna, if it's combined with the advanced antenna techniques, so massive MIMO is different, beamforming is different, but if both are combined, so it will be enormous, and that's possible from 5G and 6G. The beamforming is used, but the purpose is it will direct the radio signals to a specific user. So thereby the energy, the dispersion or energy wastage will be less. So it will be helpful for providing green technology. You are unnecessarily the energy is more, power consumption will be reduced, and also the interference. Basically, as we know, for any communication, for a proper communication, the SNR, the basic thing is SNR should be as high as possible. To have a better SNR, obviously the denominator noise should be as less as possible. To reduce the noise, the interference should be as less as possible. To reduce the interference, the beam forming is an excellent technique. So because beam forming, what it will do, it is directing your beams, the radio beams radiated by the antenna elements to a specific angles, to a specific phase. Because how they regulate it, obviously, they will be regulating it with by changing the phase of the signal, the EM wave, so they can change it. And also they can also regulate the frequency, phase, or amplitude. See, all these things are dynamically variable in the beamforming technique. So this advantage, as I told you, the interference is reduced greatly. If the interference is reduced greatly, overall SNR will be improved. Overall SNR improvement, the quality of service, the data rates will be improving, the latency will be improving. All this will come into picture. So overall user experience gets improved. Signal quality gets improved, reduces interference and user experience. And this, as I told you, this no, this is these are all again software-defined radio. Advanced algorithms are there for beamforming, and these algorithms will help in changing the phase. See, manually it is impossible. No, it will allow the dynamic adjustments will be done. Dynamic adjustments will be done, as I told you, in a scheduling period, that is 1 millisecond. That is every second. It will do this adjustment 1,000 times for every user. Just for a basic understanding of what MIMO offers. So whatever the 5G offers, I said it's not a basic. 3G talks about MIMO, basic MIMO, single user MIMO, whereas from the advanced 4G and also in 5G and 6G, it uses very multi-user MIMO. Just for understanding, small 4x4 MIMO and 2x2 MIMO is kept. So here in this case, in the 2x2 MIMO, see the single transmitter is radiating to both the receivers. That's the first transmitter, TX0 as TX1, both are transmitting. And again, you can see here also the TX0, TX1, they are radiating to this, and TX2, TX3 are radiating to this. So this depends upon the user requirement. So multiple user means here the user
బయట
one.
స్మార్ట్ బస్ దగ్గర పెట్టుకుని చేశాను వినబడుతూ ఉంటే వాడు ఆపిస్తే తెలుస్తుంది కదా పిలుస్తాం అవన్నీ
I hope any specific doubt, madam?
No, sir. No, sir. No.
Oh, okay. So the specifically here multi-users means here 4 streams are there. Here 3 users are there here. Whereas here only, depending on your usage, we can use the transmitters for multiple users, or multiple streams can be given to it. So the MIMO talks about spatial multiplexing or transmit diversity. So transmit diversity is provided here. The first TX0, TX1 case, you see, same data is sent to 2 transmitters. So transmit diversity, even what's the purpose of transmit diversity? If the radio conditions are bad, let's say for this user, the radio conditions are not excellent. Radio conditions are bad means there are some obstacles in between. There is a fading, there is an attenuation in between the, it's happening in the radio interface between the user and base station. To overcome that, this diversity is kept. So suppose even if the receiver 0 could not recover the complete signal, even the receiver 0 is having some bit errors, and there is a probability that the RX1 signal have better probability, because both these signals will not behave in the same direction, because this will be subjected to a reflection, refraction, diffraction, or scattering, etc. So both these signals will not behave in the same pattern, and that feature is exploited or leveraged in this to adopt transmit diversity. So massive MIMO beamforming, as I told you, both combination, what it is doing, see, it's a let's say this is the 5G macro base station, and this 5G macro base station, it is focusing the beam specific. Let's say this car vehicle user, the beam is specifically, some antenna elements are focused to him, and some antenna elements are focused to the vehicle too. And some maybe one or two maybe is having a voice call. For voice call, no, you need to have a that the number of resources that are allocated are as less as possible, because that is sufficient for voice call. If you are using a high bandwidth or high data rate, then you have to go multiple antenna elements are given. So here you can see even the floors, the flexibility, the granularity is in such a way that even for a different rooms also, different rules in a multi-storied building, we'll be calling it as MDU, multi-dwelling units. The multi-dwelling unit, maybe a gated community, or it may be a office complex or an IT building. So this is possible to have the focus will be there as per the requirement. So this is possible because MM waves are there and massive MIMO antennas are there, and that beam steering is there. The steering is possible because the steering beam form after formation of the beam, that beam can be steered because why it has to be steered, because see the vehicle is moving, mean that also has to be steered. That the phase of the beam should be steered. And for more better clarity, you can see here the when compared to 4G, the 5G is having smaller base stations, and the smaller base stations with massive MIMO antenna can focus the beam. See, for example, for a basic layman user, you can see in the 4G, it's like a it's like a broadcast. The signals are just broadcasted. Whereas in if you see 5G, how the signals are there, it is multicasting. So it's just one-to-one is there because of the that possibility is there because of massive MIMO antenna. Whereas in 4G, maximum will be using 8x8 only. 8x8 means you'll be having only 8 transmitters and 8 receivers. So this multicast is always a better feature because we simply don't broadcast one to all because a large number of users will not use your signal. So that is the significant change. That is a significant change. Why the 5G is having better energy efficiency. We also have seen 10x your mobile phone batteries, the power life of the mobile phone batteries or the IoT devices has improved by 10x. We have seen the first slide. So that is one of the reason. And also overall, this feature will overall improve the noise. It will reduce the noise. It will reduce the what is called as so I'm sorry. This is what is reduce. What will reduce is the interference. The signal to noise ratio will further improve. And just for having a small glance, I'm just now let me just yeah. I hope you can see it. Yeah. So this is a massive MIMO antenna, and this massive MIMO antenna is it's a glimpse in one. Just internal view of the massive MIMO antenna. There is how many are there means it's having a 64 transmitters are 64 by 64. Is they are all transceivers, no? All the will be acting like it. So these are antenna, which is a transducer, which will convert the energy from RF to EM waves and vice versa. So this here are having 64 antenna elements. The small, what is the beauty? Why everywhere array, even in second generation also, if you open a second generation antenna, inside you will be having a 6 to 10 antenna elements will be there. So what the fundamental difference here is the antenna element size will be much smaller in 5G. Why? Because we are using the higher frequency. The antenna element size depends upon the wavelength, obviously. So here using mm waves means obviously when you are using a millimeter wave, the antenna element size also will be in millimeters. When compared to when you are using a 900 megahertz band or 700 megahertz band, the antenna element size, because the wavelength is more when compared to this millimeter. So the antenna element size differ because the antenna element size that's not feasible there. Though the technology is there, because this transmitter MIMO can be implemented long back also, but of course beam steering, beam forming, and this no SDR is not there in second generation and third generation, but subsequently it has come because of the advancements and because of the flexibility of usage of higher frequency. And coming to the other important key RF technology, apart from the massive MIMO, that is the CRAN. CRAN stands for Cloud RAN technology, or centralized RAN you can say, or Cloud RAN you can say. CRAN architecture talks about split architecture. Last time also Vanishri madam asked about how the energy, the power consumptions or power levels are reduced. As I told you, much of the energy or much of the power in the base station is consumed at the RF cable. RF cable are the waveguides which we use. are the coaxial cables which you use if it's less than 2 giga. Normally we'll call waveguides when it's more than 2 gigahertz. So the waveguides are the what we call as a jumper cable or the feeder cable. So those which has the copper inside, that will be having a lot of losses. That how it is reduced by using split architecture, as I told you. The split architecture is possible because of no this two different units. So the base station it's called as GNB in 5G. GNB stands for gigabit node B. Gigabit node B means giga, or you can say giga node Bs. So this giga node Bs is having two parts. One is DU and other one is CU. DU is nothing but a distributed unit, whereas CU is the central unit. Okay. And central unit and distributed, what is the difference with? So these central unit and distributed unit are separated by one open interface. That's a fun interface. So in central unit, you'll be having the layers. PDCP layer means packet data control protocol, and higher layers like L3. So L3, as I told you yesterday, also in how in mobile communication we'll be having only 3 layers: L1, L2, L3. L3 means from transport to application layer, it will be in L3, whereas the data link layer, network layer will be in L2, whereas physical layer is always L1. So here the DU talks about L1 and L2, whereas L3, from L3 all these layers will be talked about. This will be kept in a place unit. So if you so just see how they are connected. So DU means what they're using is the DU and CU are connected by this F1. What is the F1? Physically, they are connected by optical fiber cable. So optical fiber cable will be there, which will be greatly reducing the losses, copper losses, the feeder losses. So that thereby, when you're using optical fiber, the light is a signal, and then we don't need internally also. Internally within the base station, we are having the split, and we are utilizing it for better service. For example, so centralized unit is there. Earlier base stations means in the base station, all central unit DU and the antenna will be at the same place. Now, central unit, let's take in a district headquarters, let's say small district headquarters. Metros may be different architecture. If you take a district headquarters, we'll be keeping district in a district headquarters. You will be there. In all the, or maybe in a town, we are having multiple base stations are there. If you take a town like no, let's take Mahbub Nagar, or a small city or tied to city like Mahbub Nagar. So we'll be keeping a centralized unit in Mahbub Nagar, and in the Mahbub Nagar district we'll be having let's take 100 base stations are there. 100 all these 100 base stations will be having the DU. DU will be there. So the DU are connected to the optical fiber cable. So this internal split, it's not a controller separate like a BSC, but it's like a internal split of the base station. And at the control unit, we'll be keeping a server. That's possibility is there here. So an open hardware server, it may be whatever server you want, you can keep it just for reducing the latency for the core network function. For example, as I told you, edge computing. Edge computing is a feature which, of course, with the latest slides it will come. Edge computing, what is the advantage means? That normally, what is the purpose of the network mobile communication? To provide service to users, mobile phones. These mobile phones right now, apart from the services like voice on the data communication, so many features are there. Like OTT, they are watching, or they can see the maybe the YouTube content, or maybe the any other the high intensive bandwidth resource intensive applications. So any resource intensive application or any bandwidth intensive applications like OTT movies or YouTube videos or any other content download. I suppose in that area, suppose IPL is going on, everybody, most of the people will be watching IPL in that area. So what they will be doing is instead of having a multicasting for everybody, instead of having a separate pipeline from end to end, maybe the let's take a Star Network, Star TV is there, and which is providing this IPL live, and in order to avoid multiple end-to-end connections from the user to the Star Network server, you'll be having multiple bandwidths blocked. So that may lead to congestion. That is will be difficult. So that to avoid it, what's happening is at the to release the core network or the end-to-end networks, whatever live TV is coming, or whatever the many YouTube people most watched videos are there. Let's say OTT recently, let's say one movie is released. Recently released movies are there. So all these content will be downloaded, and it will be stored in the a server which is near to the, or which is co-located with the CU, centralized unit. So thereby the latency will be reduced. One thing, the user will be having better experience, and also the choking of the core network, end-to-end networks will be reduced. So this is one of the advantage for the 5G CRAN. So for CRAN network architecture is having multiple advantages. Like first thing is I told energy efficiencies, and the reliance on feeder cable, the capex, capital expenditure is reduced. One thing, because you need not you need not deploy the waveguides, because waveguides are costly when compared to optical fiber. That is one thing. Operational expenditure, because energy efficiency are improved, means power consumption is reduced. Operational expenditure, and also user experience, because edge computing you are doing, because we are keeping the server. It's called a CDN service, actually content delivery network. So that CDN service, the concept is there. Even the data communication, even the ISP networks also, that same concept is realized in the from 5G also. From 5G and 6G, it will be there. Of course, it depends upon the user. Of course, the operator's policy also. Operator can keep it. It's not mandatory. It's not optional. But the CRAN tech offers this technology. And you can see here, before implementation of CRAN and after implementation of CRAN, you can see here, DRAN means a distributed RAN architecture. CRAN is a cloud RAN or centralized RAN. So you can see the DRAN means before CRAN, what was there means it's standalone base station. A base station, how it will be there, just for your idea, if you take any base station, you know, if you go, so many base stations will be there. Now, if you just take Hyderabad, you'll be having more than thousands of base stations for every service provider. So thousands of base stations will be there. Every base station, you will be having, one base station equipment will be there, in which you'll be having the baseband unit as well as the RF unit. That's called RRH or RF unit. So RF function will be like modulation, filtering. There's no Manishri madam asked about the various filters or adaptive filters will be there, and then power amplification in the forward direction and reverse direction low rise amplification. All these things will be there in the RF unit, whereas BBU talks about the actual baseband signal processing. The actual digital signal will be there, no, that baseband signal before the modulation, digital modulation, and that will be done in the BBUs. So this is the major core equipment that will be there in any base station, in any base site. We will be calling it as site. This box is called as site. In that site, this equipment is the actual base station electronic equipment, and to connect it to the central office, to connect it to the core network or central office, you should have a transport capability also. Transport capability means, again, they should be connected through an optical fiber for long distance communication, or either it will be called as a backhaul. So for a base station, it cannot be a standalone. No, standalone does not serve any purpose. It should be connected to the network. So how it's connected to the network or the core network? Through a transport connectivity. So a transport equipment will be there, maybe a CPAN, maybe an MNG PAN, or maybe we'll be calling it as a MAN network. So different types of transportation equipment will be there. Usually 95% all optical fiber transportation technology will be there. Or you can use a DMW, digital microwave. You can also use a backhaul as a wireless point-to-point line of sight links also. And to power supply it, a UPS is required, and also uninterrupted power supply, or maybe a power plant to convert the AC supply to DC supply, and also a battery system should be in case of any power failures. A battery should be there in the UPS to connect it to the to provide the uninterrupted power supply, and the AC unit or cooling unit. AC air conditioning nowadays for outdoor units are not mandatory. In the indoors, it will be there, but even cooling units, some cooling units should be there. We will be having fans, cooling fans will be there, or exhaust fans will be there, or cooling, latest cooling ventilators are provided. So that arrangement, these all arrangements will be there for every site, and these are connected through optical fiber to this, and of course connected to the antennas. As typically we'll be having three sectors, no, cell sectoration, as I told you, will be there, and this is the case. But if you move on to CRAN, what's the beautiful thing it is having means everything is got, the capital expenditure is greatly reduced. You see, in the site, no, only except the antennas and RRUs, nothing is there. So RRH, which is there, the base station equipment, is they are kept at the antenna on the tower only. These are called as RRH, which will be working as a because IF signal will be coming from the BBU. So these BBUs which are there here, the split, no, BBU RRH is split. RRH is kept at the antenna, whereas BBUs are brought down to CO. So BBUs are baseband units, because baseband units are the one which will be processing what is baseband signal, the actual information signal. And see here, the greatly capex opex expenditure is greatly reduced, and energy efficiencies are there, and which will be helpful in sustainability also. So it's a green technology. See, that is a complete green technology. Not only green technologies, a lot of advantages. I told you, no. So this is how the networks are connected. See, obviously, what's the purpose of this backhaul connectivity? To connect it to the core network. So we had discussed yesterday about a core network in detail. Service-based architecture will be there, and softwareization will be there, and cloud will be there in the 5G core. Talking about the HETnets, heterogeneous network, the name itself you can see, it's like opposite of homogeneous. Homogeneous means all the cells are of same sizes, which is not at all case, which is not at all possible. If it is the case, it will be completely inefficient network, because if you don't have any the customization, unnecessarily we are using the bandwidth in the low band, in the low dense areas also. If you're using high bandwidth, there is no purpose. So in the it depends upon the density, it depends upon the coverage requirements. So coverage requirements, capacity requirements, and quality requirements, all these three important requirements are considered while designing the size of the cell. Heterogeneous networks talks about multiple sizes of the cell, and you may be asking why it's not, whether it's not there in 2G. It's there in the 2G, it's there in the 3G, it's there in the 4G. What is the special in HETnet in 5G is the mobile phone can coordinate, can interact with these multiple sizes cells at the same time, or it can it can see, let's say in the same area you're having a microcell which will be having a range of 1 km. You're having a picocell which is having a range of 100 meters. They're having a macrocell which is having a 3 kilometers range. At the same time, whichever is beneficial to it, wherever the energy efficiency will be there, wherever we can reduce the uplink, it can use microcell. Downlink, it can use the picocell, or downlink, it can use the macrocell. So that flexibility, that customization is there. HETnet, that coordination is there because of the possibility of the algorithms, because we are using SDR algorithm. That's the main, you can say, enabler. So these, as I told you, various nodes, not only heterogeneous network talks about microcell, or any other cell, even Wi-Fi hotspots also. They can integrate with the WLAN networks also. That is also one of the key feature. Apart from it, integration is possible to provide seamless connectivity. Seamless connectivity is the idea. So there is no handoff will be there, and also the traffic distribution will be there, and the capacity distribution will be there. This is the advantage. So as I told you, this heterogeneous will be using what is called as DAS antennas, distributed antenna systems, which has capability to interact with the multiple cells. Okay? And what is the advantage of using it? So network performance, the data rates can be improved. The user experience, the data rates are better means the user experience will be better, latency will be reduced, etc. And other advantages for the operators are load balancing can be done, as well as resource utilization. Whatever resources that are available, that can be much better, they can be utilized in a much better way. And one more key technology that is there in 5G or HETnets is the role of AI. AI is also used because to have the better analytics, to have the dynamism. As I told you, 1 millisecond it will verify means 1,000 times it will verify. 1,000 times if the same data is there is no purpose of verification. Why such as granularity is there? Because the customer can move from anytime. Customer will be moving anytime. And also if at this point of time what the data is there. So artificial intelligence, as we know, the machine takes the help of the data science tools or the machine learning and deep learning tools. So a lot of logs will be generated, the base stations and then the BBUs are the users. Every mobile phone will be generating a lot of logs. Logs means a radio conditions at every millisecond you generate, and you'll generate what is the uplink power you're using, what is the downlink power you're using, what are the resources, physical resources you're using at every point of millisecond, and this data will be simply say will be they are siloed, and they will be stored in the silos, and that data logs will be input to the machine learning, because earlier days we don't have the ML and DL techniques. Now ML and DL techniques are there. So this the large data can be analyzed to optimize your network. So optimization will be done in a much more better way by using AI. So headnets, its possibilities are which cell, microcell or macrocell or picocell, which should be given uplink, which should be given downlink, or which should have multiple cell coordination, or both, how many cells should have downlinks. You can have microcell and macrocell, both can give downlink also, or only one can give downlink. Which there should be some basis, no? That basis will be the AI, that the ML and DL techniques are used, and this is called as actually SON. There's already is implemented in the release from R12, 3GPP R12. SON has been established. Like no, it can do the networks are capable of doing self configuration and self optimization, as well as self healing the network. And headnets in 5G, as I told you, it will provide the low, not only the high data rates, but also can provide you the low latency. That also is possible. That use case also it can provide. And so diverse requirements, and the main headnets concept because of the small cell requirements. And if you take the in 6G also, these headnets are required, because 6G talks about advanced technologies. They're also talking about not only the gigahertz, they're talking about usage of terahertz frequencies. You can say GNB, we'll be calling the 5G base stations as giga node Bs. We'll be calling the 6G, as of now officially it's not there, but tera node Bs, TNBs. In the third generation base stations are called as node Bs. Fourth generation are called as ENBs, evolved node Bs. Fifth generation node Bs are called as base stations are called as GNBs, gigabit node Bs. Whereas sixth generation, most probably they will be called as TNBs, tera node Bs. So these are the things. And this, of course, the purpose in 6G AI is included, and terahertz are included, and then machine learning and AI techniques. What will happening is the networks will become fully autonomous. So that is the major keyword: autonomous, networks. So this for driverless cars are many applications, like, because driverless car is a major hit application. Autonomous vehicles or robots, automatical robots for implementation of smart city projects. Smart city means the disasters, any disaster discovery or disaster alerts, and then traffic signal management, and then waste management. And we have a lot of challenges that are there in the current world. So, and when smart cities is a great challenge, and to implement smart cities, the adoption of technologies are required, and this will help in much better way. So apart from it, the other which everybody is waiting for, all the common person is waiting for, is the which we see in the movies, the holographic experience, holographic communication. So where they need not know currently when we are having a video call, a WhatsApp video call, so just opening the mobile phone. So holographic, as we all know, that because of that high speed, that much better immersive experience will be there. The image will be appearing before us, and then for all that we need to, of course, much better speeds are required, and thus as possible from 6G. Still, these are all in use cases, and still they are in the development stage. And finally, as I told you, in 5G, the main key technology in 5G, not only 5G, 6G also, because 6G also same thing will be there, edge computing, but some more in 6G I will just discuss after a while. Say the talk about, see, as we know, any network will have an access network and a core network and the external network, which is an internet, and a data center cloud will be there. This is the normal ecosystem of the ISP service provider. But this edge computing, as I told you, it talks about to reduce the processing, to reduce the delays in core network processing, external network processing, and the cloud network processing. So what are frequently watched videos or recommended videos are the much demand stuff or content will be pre-downloaded from the cloud to the MEC cloud. The MEC cloud is much very near to the users, so they are very very near. So thereby the latency reduced. That's what we discussed in the previous slides in the CRAN architecture. So this slide I think will give you better picture of mobile edge computing. So mobile edge computing brings up on the table a lot of advantages like low latency, and you can also implement better cyber security because a server which is very near to the user can have you can have multiple layers of firewalls. You can keep a firewall. No, from 4G, 5G, that the usage and consumption of data is much increased. The purpose of these networks are only for data, and the data is there. Obviously, we know the threats of cybersecurity. We all are watching in the media, and everybody, many of the people are sufferers from the cybersecurity threats. There are so many traps are there, so many cyber hackings are there. So that can be curtailed with another layer of security at the MEC level, at the cloud, at the MEC level, which is very near to the user. So that is also one of the biggest advantage. And data analytics will be much better because you're using AML, and then if you're having faster data, and it can have better analytical data will be there. So expand interoperability will be there, expand interoperability and lower storage cost. So and that is also one of the advantage. So we need not invest more in the cloud. And coming to as I told you, the frame 5G key technology in RF is the scheduling will be there, and the scheduling feature means every 1 millisecond. You see here, this is a frame. The radio frames sizes in 5G is 10 millisecond. In the 10 milliseconds frame, you will be having 10 subframes. Each subframe is called as 1 millisecond subframe. And again, in 1 millisecond subframe, which is called one time slot. So you will be having the OFDM symbols. The number of OFDM symbols, minimum 14 symbols, but the symbol rate depends upon the modulation. Suppose if you are using QPSK, one symbol is equal to 2 bits. If you are using 16 QAM, one symbol is equal to 4 bits. That means in the same slot, if you are using QPSK, 28 bits will be there in QPSK. If you are using 16 QAM, 14 to 4 means it will be using 56 bits. Suppose if you are using 256 QAM modulation, when it can be used if the radio conditions are better. If the radio conditions are better, instead of sending the redundant bits, we can use all the data bits can be transmitted, information bits can be transmitted. So we can use 256 means it will be around 2 power 7 bits can be transmitted. 128, sorry, 2 power 8. 2 power 8 is 256. So 256 means 8 into 14 number of bits can be transmitted in one slot. So that is the kind of advantage if the radio conditions are better. And in 4G only 15 kilohertz is there, as I told you. In 5G you can go up to 30 kilohertz, 60 kilohertz, up to 240 kilohertz. So these are the different flexibilities that are there. Why we vary mean depends upon the requirement, depends upon the what kind of area we are talking about. And the broad comparative analysis which we discussed. So when we are going from 3G to 5G, the throughputs are increasing, and but the main reason is this also I told you about CDMA here. In 4G, 5G we are using OFDMA. The major advantage you see, and 5G, 3G only 5 megahertz is the bandwidth, whereas in 5G it is using the bandwidth more than 100 megahertz. That is a major key RF technology. And thereby latencies are reduced, and the antenna sizes are different, applications are also different. So AR, VR, we're talking about vehicle to V2X means vehicle to everything. V2X exceeds everything. Vehicle to vehicle, vehicle to phone, vehicle to device, vehicle to application, and robotics. So autonomous robots also one of the key feature. So autonomous robots, just like driverless or autonomous vehicles, autonomous robots will be coming to picture, which will be playing a key role in the smart city projects. So is there another glance of in 6G? If you look at the idea is by 2030 it will be deployed, and 6G, when if you are talking about 5G, the capacity is 1 million devices in a square kilometer. But if you talk about 6G, it will be 100 million. So we can say it will be around 10 power 7. And 10 power 7 means of 10 million. 10 million means it's about 1 crore devices, 1 crore devices per square kilometer. So more capacity will be there because 6G talks about terahertz, more better bandwidth will be there compared to 5G. And per meter square, you will be having better speeds. Spectral efficiency, you see, the very stark increase is the spectral efficiency. 5G talks about 3x. The 5G is talking about spectrum, overall spectrum can be utilized from 15 to 30% only. Whereas in 5 times it is increasing. 5 times it is increasing in arrangements, around 15x spectral efficiency will be there. Energy efficiency is also 10x more than 5G. And the latency is improved now 10x to 100x. And even the speed, mobility speeds, 5G talks about 500 kilometer per hour, whereas 6G again double the speed, the mobility speed it can support. And we talk about Gbps in 5G, whereas in 6G talks about terabits per second. So that's the kind of improvement that 6G talks about. So what are the key features apart from the features which you have seen 5G? All are there. Whatever features we have seen, 5G adopts all these features. Apart from it, new frequency waves are there. That is see what are the features? Terahertz frequency bands are there, and advanced MIMO and sophisticated beam steering is further sophisticated. So more advanced algorithms are there. Further, more advanced algorithms are there, and then other features are like ISAC. ISAC stands for integrated sensing and communication. So sensors are being utilized in a larger way in 6G. So in ISAC, integrated sensing and communication. Advanced RF front ends are there. So and then cognitive radio technology techniques and then metamaterials and also in antenna design. Let's see some of them. Then terahertz means it talks about frequencies from 100 giga to 10 tera. So obviously, more higher the frequency and better the the throughput, because as per the Shannon's law, you have seen the channel capacity is proportional to the bandwidth, the first essential bandwidth, and later to the log SNR. So log 1 plus SNR. So and we also have, so how the capacity is increased? One way we are increasing the frequency. The other factor is SNR. SNR also how you are working on SNR by reducing the noise to as much as possible. By using massive MIMO antennas, by using beam steering, noise will be greatly reduced. So SNR also improves. So all factors which are required for improvement of channel capacity is increased. So terabits per second is possible. And extremely high frequencies, as I told you, low latencies, and sub-tera frequencies like 90 to 300 gigahertz, which will be key focus for implementation. And so this tera, not only tera, sub-tera is also used. So depends upon the multiple frequencies are will be there in 6G. 6G talks about this ISAC. ISAC talks about the same wireless signals will be used for both transmission, and also these wireless signals also will be used for gathering information about the surrounding environment. So these same signals will be also used to say what's the temperature around it, what's the humidity around, and what is the sunlight around, what's the heat around, what's the kind of any environmental changes around, what are the kind of CO2s around, what's the kind of nitrogen levels around. So all these things will be sensed. It will gather the information. Essentially, what will happen is this single system will be performing both this function. What function? The transmission function, communication function, as well as sensing function. So which will utilize further, definitely spectrum efficiency is further improved. And the hardware separately need not go for a sensor devices like an IoT. So, and the advantage will be the precision location and gesture recognition, and then environmental monitoring, advanced robotics are the some of the key things for this. Localization means you can just particular geotagging how you're using. By using the sensors, we can use it. So these are the use cases of ISAC: autonomous vehicles, smart manufacturing, healthcare, disaster management, because when tsunami is going to come, or earthquakes, which are prevalent these days, and cyclones, floods, and then unexpected tornadoes, are which we are seeing day in and day out. These are recent times like Wayanad floods, or then Wayanad landslides, or the Chennai floods, etc. These all will be greatly, because the signal will be everywhere now, so the sensing capability of the communication network will be greatly enhanced, and will have better experience. And of course, because the higher speeds, augmented reality, real-time environmental information will be there. And coming into the cognitive radio techniques, so the allocation, the cognitive radio means as we discussed about head nets, and as we have discussed about the multiple carrier aggregation available. Because of this cognitive radio, because of the advanced ML algorithms, which spectrum is to be allocated at that moment, that also will be taken care by this cognitive radio. So whether you have to use the orthogonal multiple access, whether you have to use non-orthogonal multiple access, or whether you have to use the hybrid multiple access, so that flexibility is there. So overall, the purpose of cognitive radio is to reduce the interference to as low as possible. Thereby, if interference is reduced, means overall capacity will be improved. And finally, metamaterials. So metamaterials are the miniature materials, we can say. That is also this usage of this metamaterials will help in enhancing the antenna performance. So we can use miniature antennas. We can improve the gain of the antennas because of the metamaterials. Bandwidth will be wider, and then the beam steering or beam forming can be more precise. EM waves can be more better controlled of these metamaterials, and then and of course the wider bandwidth capabilities it can have. And basically the purpose is, if you are using metamaterials in antenna design, it can precisely control the radiation pattern of the antenna. Radiation pattern of the antenna is the beam. So for better advanced antenna technique, beam forming and beam steering, metamaterials help in better way. So as I told you, in 5G, like 5G, in 6G also, the adoption of AI is in a much better, in much more higher proportion. So for personalized service, personalized, customized, you can say services. Okay. So what are the challenges ahead? Challenges ahead are no, to implement it, you need the infra capex is a challenge, opex is a challenge, and infrastructure investment, deployment will be a challenge, because you need to have a good knowledge for that, and regulatory frameworks should be there, because they will be having multiple frequencies, multiple bands will be used. So regulatory frameworks should be well defined, so that there is no issues between the service providers, or there's no issues between the interoperability of the products, etc. And now security privacy also is a new challenge, because data will be more prevalently used, and that should be regularized. And finally, the unified standards should be there for widespread usage of the technology. So many countries already they are working on it, researching on it. The challenges will be development of metamaterials will be there. Will be there, and that's the future outlook. And then the for development of RF technologies, there should be a continued collaboration between the academia, the researchers, industry, and then governments. And as you know, in India, our Indian government is very much futuristic in 6G. Already with the help of Nokia, they have established a 6G POC, 6G pilot testing lab in Bangalore already. So and then 6G, and already government has given the 6G vision document and white paper on the technology. And these are some of the drivers. Government has pivotal role, playing a pivotal role, and government is also investing in the startups. They are sponsoring many startups for development of use cases for no, deployment of the services. So, and many countries are working on it. So, this is the future outlook of the 6G. And thank you for your attention. And we have discussed about 5G, 6G, RF technologies. The floor is open to questions. And
Good evening, sir.
yeah, good evening.
Sir, What are the use cases of HETNet, sir?
HeadNet, the better use case is when in dense urban area. In dense urban area, we'll be having, as I told you, multiple cells will be there. In multiple cells, for example, in overlaid cells are there. We will be having a macro cell, and we will be having microcells, and we'll be having a number of picocells. So you will be having, it's like concentric cells will be there. Concentric cells of a macro, micro, and pico will be there, and the user can connect to all these cells at the same time. The use case will be in a dense urban, let's say, the possibility, let's say, in expressway, in the dense urban area, expressways are there, outer ring roads are there. In some areas, there is no exits will be there. There is no, we cannot park also. So the vehicles are if the customers are having higher mobility, they will be attached to, the macro cells. And some customers will be attached, which are having stationary customers, they will be attached to the micro cells. And some customers which are having the almost zero mobility, they will be attached to pico cells. And for example, the zero mobility customer, they want higher performance requirement. They want much more better download facilities, but they're demanding more throughput. So some of the bandwidth they can take from macro cell also. A downlink, the user who is stationary can get some bandwidth from the pico cell and some bandwidth from the macro cell. And some at the same time, you can also get a coordinated from micro cell also. That flexibility is there, man. And he can say downlinks from some cells, and uplink can be used. Maybe suppose if he is in a particular area where uplink is, he can have he can spend low power to transmit any data in uplink direction to a macro cell. He can do it. That flexibility is there. That best case is the dense urban area.
So is there any disadvantage, sir?
Disadvantage is the complexity, no? Because without the software capabilities, without the software implementation, it's not possible because it's dynamic. We are doing the scheduling every 1 millisecond. So if any issues are there in the software, if any issues are there in the scheduling, in the data, such a lower granularity, definitely you will be having the some more reliance on the software will be having. That's the only disadvantage, because you are having more risk factor. But of course, since the softwares are much more
interference, sir, more interference.
Interference will be the HeadNet concept is implemented because it can control interference, because the whatever macro cell frequency we are using it will not be repeated in the micro cell, and the same thing will not be repeated in the pico cell. So the software will see that though they are using the same frequency in the OFDMA, it will see that the whatever subcarriers we are using in the macro cell will not be repeated in the micro cell, and the same the group of subcarriers which are used by the micro cell will not be repeated in the pico cell. The software will be looking these things.
Oh, okay, sir. Is there any relation between the dynamic channel allocation and HeadNets?
Dynamic channel allocation is both are different, madam. Both actually dynamic channel allocation will be there from second generation. Dynamically, channels will be allocated from second generation also. That is there. The channels will be dynamically allocated only in the CS2. In GSM also, suppose you are using packet switching, you are using data. Unless for a voice call, dynamicism is not required. For a packet call, for a data session, we don't know when the upload will be there. It's like a we can say discrete traffic. So data traffic is not continuous. Sometimes I will be using YouTube. Sometimes I will be using Google Meet. Sometimes I will be only having voice call. Sometimes I will be idle mode. Sometimes it will be in a plain mode. Sometimes, so it's a discrete traffic will be there. So that discrete nature, because the packet switching will be adopting. For packet switching, we will be using the dynamic channel, madam. Dynamically, depending on the bandwidth, it will be allocated. That's there. But HETNet is a great feature that's started from this 5G.
So in HeadNet, the base station will automatically tracks the user depending upon the speed of the user, different users, and it will allocate the cells, different
Yes,
cell
madam.
size.
One of the factor, yes, correct. One of the factors it will what it will monitor, madam. It will monitor the mobility, the speed. Apart from it will monitor the throughput requirements. What is the QoS requirements? It will also monitor the latency requirement. It will monitor all these things because multiple facts it will monitor, and it will then decide the resource as well as the what cell it has to provide the signal.
So it all done by the AI, yes, sir, algorithms.
AI is also helping it, madam. Currently, headnets with the help of AI will be much better. But without AI also, headnets are possible now. Headnets are already existing.
How the base station is
Software,
tracking, sir?
software. We will be having control center now, madam, because we will be having all these base stations are connected to a core network. In the core network, we will be having what is called as no, MME means mobility management entity will be there. That mobility management entity is connected to all the base stations, so it will oversee that. And also these base stations, they are connected by an interface. Earlier, before 4G, the base stations are not directly connected. But as per the standardization, the base stations are also connected. We need not go to core network for the control. Core network also will be there for control, but apart from it, another level of implementation, another level of providing the signal, and another level of controlling this spectrum is the neighboring cells. Neighboring cells means, let's take Koti, Abids, and then let's take Sultan Bajar. All these areas will be connected by one X2 interface. These are connected by X2 interface, so they can they can take the decision by discussing among themselves, and this is called as we have technologies are there. These are called as actually coordinate multi-point. COMP is one technology, and another thing is the interference. Whatever interference it will be there, that also will be controlled. Those things are there because of the neighboring cell interface connections, madam.
Okay, sir. And you have discussed about another topic, which is massive MIMO, sir. Is it existing now, sir, and in anywhere?
Yes, madam. We are already there. It's reality only. Whatever antenna I have shown you, the
Yes,
antenna,
sir.
whatever I have shown you, the massive MIMO only.
64
It is
by 64.
it's
64 by 64 antenna.
yeah, it is 64. Yes, madam. 64 by 64 is the massive MIMO antenna. It's a basic one. The basic 64 by
Okay.
64 is a older picture in our laboratory. It's a old one, madam. But
Okay.
by recent, we are also having more than that. If you go to IIT Hyderabad, they are having a 6G test bed in the open. They have so what they have done is I have that personal
Narrowband
photograph.
IoT. Narrowband IoT they have implemented.
And NB-IoT is there, and also what they have done is before their in the open lawn, they have kept a big and massive MIMO antennas are they kept it. So they are working on that. I have seen physically big antenna structure is there because it is not
With
completely
how many
miniaturized.
antennas, sir? With how many antennas?
There I have seen 512 by 512 antennas.
Okay.
512 by 512 antennas.
Okay.
It is
Sir, if
possible
we
because
use
wavelength
massive
is
MIMO,
madam.
sir. If
Wavelength
we
is
use
again only, no, madam. That's why it's possible. Yeah, you're telling something.
yes, sir. If we use a massive MIMO antenna, what would be the radius of the cell?
A radius of the cell will be hardly, as I told you, less than 200 meters or 100 meters, something like that. So it will be a picocell only. Picocell will be in the range of hundreds of meters. So with the help of relays, we can extend to 200 meters. But massive MIMO antennas hardly in the picocell area, 100 meters area, around 100 meters, 200 meters, not more than that.
Sir, if we have an 8x8 MIMO antenna with 200 meters radius cell, how many users can at a time connected to that base station?
That advantage will be because it depends. See, for example, technically, let's say it is using 512 by 512 massive MIMO antenna. Okay, technically speaking, each antenna element, if you are allocating to one user, 512 can talk at the same time. No, 512 can have that service at the same time. On top of it, see, as I told you, it's a discrete traffic number, and the customer traffic is not continuous traffic. Even though you're having a beam from an antenna element, or you can have multiple antenna elements focusing at multiple beams to improve the redundancy or to improve the spatial multiplexing. And see, on top of it, your scheduling will be done 1,000 times in 1 second. So let's see, what in every millisecond you need not have the data requirement. Every user, the 512 users in a particular area may not be using continuously. No, sometime right now we are using Google Meet. After 5 minutes now, our session will be over. Maybe I will be keeping only notification mode will be there. I don't will be using the data. No, my video will not be there. My projection will not be there. So every millisecond the changes will be there. And so 512, not only 512, because of this concentration technology, you can have, it can be maybe 4x or 5x or 10x also, more than that. So dynamically it will be allocating. So the exact number of users we cannot tell, only the live data only it can tell. But it will be much more. You can say 10x or 100x, maybe more than 512 also, because that scheduling is there.
Oh, okay, sir. And you have also discussed about metamaterials. And one technology is there which is intelligent reflecting surfaces, which is using metamaterials.
Yes, madam.
So, what is the advantage of this massive MIMO over intelligent reflecting surfaces, sir?
Actually, the massive MIMO is different, madam. Actually, massive MIMO is talking about only the antenna size only, but whereas the metamaterials is talking about the further refinement, further advancement of the antennas. Whatever antennas that are available, it is further refined. So if you are using now, it's like a metamaterials are what they are cutting edge technologies, because that practices. If you follow that practices, no, what will happen is much more. There maybe the radiation, the EM waves, the control, the precision of the beam formation, or the precision of the beam control will be much more rapid. The efficiency is improving. The antenna, the gain efficiency will be improved. The when the antenna propagation with the front lobe projection or the back lobe projection, or if you're tilting the antenna, the exact tilting of the antenna, changing the azimuth of the antenna, whatever the antenna characteristics are there, there will be definitely will be having impurities. No, that will be if you in the case of metamaterials, it is that the efficiency of the antenna is increasing. So massive MIMO antenna and metamaterials, they are all complementing each other.
Okay, sir. And last question, sir. One, it is a general question. I have a doubt from sir. How international call is established, sir? Is it through circuit switching, whether it is through circuit switching or packet switching? Long back we have a trunking call like that, but nowadays how the international call is established?
ISD calls, the nature of the call establishment has not changed, madam. Suppose if an ISD call is there, if you're talking about only voice call you're talking, madam.
Yes, sir, voice call.
So voice call, if you're talking about a landline network, if landline is not almost there, but if you're talking about a landline, it will be using circuit switching. But as of now, except BSNL is having some landline exchanges, and we are providing next generation network. But almost all, we are using 99% of the cases. Circuit switching is almost obsolete, madam. We are not using for voice call or for a video call. For the data access also, now packet switching is used. And for example, how it is connected means for an ISD call. So usually the exchanges, local exchanges will be there. For example, if you're talking about a mobile network, how a mobile ISD call will be there means all the base stations are connected to the core network, as I said. We have a core network in a circle level. Circle level means state level. So entire Telangana base stations are connected to the core network in the in the Hyderabad area. The Hyderabad core network is connected to the our Chennai International Gateway. Chennai International Gateway through optical fiber only. So Chennai International Gateway, from Chennai International Gateway, and we have International Gateway at Chennai, Mumbai is there, and Calcutta is there. So these areas where we will be having the submarine cables connected to the international stations. So from Chennai International Gateway, which will be gateway means where multiple networks will be connected there. So from international calls will be there from that. So whether the call should go to Chennai International Gateway, Calcutta, or Mumbai depends upon the traffic distribution or the policy of the operator. From Chennai, it will be going to the maybe from the Middle East countries if you want to talk.
Hello.
Hello, sir.
Sir is in mute. Anup sir, sir is in mute.
Sorry.
Sir.
Yeah. By mistake.
International gateway. So I'm sorry, I have not seen that. International gateways. You understood what I told you? Chennai International Gateway, Mumbai International Gateway.
Yes, sir. Yes, sir.
Similarly, international gateways from Hyderabad, connect network, core circuit network or core packet switch network. They are connected to international gateway, Chennai, Mumbai, and also Calcutta, madam. From international gateway through submarine cables, they are connected to the respective countries. Some Middle East countries, some or maybe Central Asian countries from Calcutta, or North American countries, or the European countries from the Mumbai. Like that, depending on your call, the traffic will be diverted from there, and again you will be having we'll be having some agencies. So directly the call will see. We cannot have establishment with every operator. In how India is having multiple operators, in US also different state, different operators will be there. So again, a mediation agencies will be there, interoperable agencies will be there. So like how MNP is possible right now, the international gateways are connected to an MNP like server or mediation like server. From there, it's connected to the respective operators. That's how it's connected, madam. ISD calls.
Okay, sir. Does the call establish through satellite if it is an international call in case?
Yeah, satellite, as I told you, the international gateways are connected through submarine cables, that is undersea cables, as well as satellites also. But the bandwidth currently provided by satellites is very less, when compared to optical fiber cables, that is submarine cables. The bandwidth is less than maybe 10 to 20% only, around 10% only will be satellite. 90% of the bandwidth is catered by the submarine cables only. But in future, we are talking about right now, you're in the media, you are seeing now, Starlink, which has already started services in many countries. They're also trying to enter India. So they are trying to establish low Earth orbits. Right now, whatever satellites you are using are geostationary orbits, in the geostation satellites only. So low Earth orbit, LEO orbit satellites also being manufactured, being deployed by the Tesla. That is, the Starlinks. So Starlink, so they are trying to do that. Maybe if that is completely, no, they want to deploy more than thousands of satellites in the low Earth orbit. Thereby, they want to provide the complete bandwidth to the satellite. Currently, the number of satellites available are not sufficient to provide the bandwidth requirement of the internet.
Okay, sir. Thank you, sir. Thank you very much, sir. Your session is so informative, sir. Thank you, sir.
Welcome. Any other doubt you can ask, or
Participant? Dear participant, any doubt? Any more doubts? Okay, sir. Vivek, sir.
Yeah, madam. Thank you, madam.
Thank you so much, sir. It is my privilege to extend my heartful thanks on behalf of all, sir. Even though I know your busy schedule, even though that you are accepted my request, you are spending more time with us. Thank you so much, sir. Your talk is not only enlightening, but also thought-provoking, sir. Thank you so much, sir.
Thank you.
Very
Most
informative.
welcome, madam.
Yeah.
Once again, thanks. Thank you, all the faculty members, for their patient listening, and also
No,
mainly
no, 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 no.
Varish.
This is very interested. Very much interesting, sir.
Thank you, madam.
Yeah,
Thank
so
you.
informative, sir. Thank you so much, sir.
Okay. Thank you for your kind words, and once again, thank your management also for providing this opportunity.
Yes, sir. Yes, sir. Dear participants, please fill the feedback forms. I have already shared in the chat box. The next session will start within 5 minutes. Already sir is ready.
Should I stop recording?
Wait. Stop recording. Stop recording. I'm stopping.
Okay.
I stop recording.